The existing problem in the industry is really bandwidth. I mean, you have Amazon Prime, you have Netflix. If you order it, you want it immediately.
And as more and more the content moves to the cloud, that strain moves to the cloud. Those cloud providers have to figure out how to deliver more bandwidth, and they have to do it cost effectively. So we have to help to enable that, to develop the parts that will go into the equipment so that they can deliver that next generation infrastructure so we can watch videos on our cell phones. I'm Nathan Tracy. I'm a technologist in our system architecture team, and I'm also the manager of our industry standards efforts.
I'm Lucas Benson. I cover a lot of our high-speed I/O and our next generation interfaces.
When we started off the microQSFP development effort, what we did is we looked for a way to reduce the footprint of the connector, i.e. increase the density.
We have a customer problem. We're sitting at a table with one of the large data center information providers, and they said to us, if you can fit up to 64 ports on one line card, that would really help us solve our problem. We viewed it as a tipping point in the industry where customers cannot use existing interfaces to get exactly what they need. The biggest challenge there is when you have 64 ports of 3.5 to 5 watt transceivers all plugged into a faceplate, as well as the high power silicon to support it. We needed to change the thermal envelope of the interface to work well with the entire ecosystem. For microQSFP, we realized that we could almost double the thermal capability of the entire solution by integrating that heatsink into the plug itself.
And so now we've really created this counterintuitive system where the more ports you add, you actually get better and better thermal performance, which has never been the case in the past.
Going to a customer with something like microQSFP is a little bit difficult because it's something new that they have to adopt into their infrastructure. But what we did was we actually built a 72-port thermal demo, and we showed that it's possible to cool up to 72 ports in a 1 RU line card, up to 7.5 watts. And in the past, nothing like this has ever been shown before. So when we go to a customer and we put this down on the table, all questions are out.
So it's one thing to develop a great technical solution. It's a whole nother thing to figure out how to bring that to market. So in this case, after we had developed the fundamental pieces of the microQSFP technology, we then went out and we talked to a number of our customers and other members of the market ecosystem. At that point, received the encouragement to go ahead and start an industry MSA, a multi-source agreement. And in that multi-source agreement, we initially had 12 of the leading companies in our industry. So these guys were able to bring all of their technologies to this and work with us in coming up with a solution that would have broad appeal across the industry and would have a built-in ecosystem.
This is the most significant project that I have ever worked on, as well as many of our engineers, and we know that we've changed the industry.
We really have worked closely across the whole industry, all the right people. We solved the key problems that they laid before us, and now we've implemented it into a cost-effective solution. It's in the process now of being deployed to market and truly is going to leave a mark on the industry for many years to come.